Hello, everybody, and welcome back to another Mr. Farney Earth Science video. In the last video, we spoke about lunar phase basics. We talked about the phases of the moon, the 8 different phases of the moon, and a couple other fun moons you can get, like the harvest moon, especially during, our autumnal season. In this video, we're going to talk about eclipses. We're going to talk a little bit about lunar eclipses first, and then get into solar eclipses. Now, we're just going to kind of get into the terminology a little bit, get into eclipse basics here. So we're going to try to keep it as straightforward as possible. Before we talk about either lunar eclipses or solar eclipses, we need to, first recognize a couple things. Firstly, the moon's orbit is slightly tilted, whereas a lot of the planets orbiting around the sun, we're all on, the same elliptical eccentric orbit. Thank you, Kepler's first law. Whereas the moon, since, it didn't originate at the exact same time that planets did in that early, nebular, the early planetary nebula, its orbit is not going to be necessarily aligned the same way. So the way our moon formed, it has a slightly tilted orbit. So it's not perfect in line with the Earth and the sun. It's slightly tilted, and that's something that we need to recognize. However, even though it's tilted, it is elliptical. So like we've learned with Kepler's first law, we put whatever is the main source of gravity at one of the 2 foci points. The Earth is on the left focus point here. And like when we were talking about different terminologies to describe where a planet is in relationship with the sun, we had perihelion and aphelion. We have 2 words to describe when the moon is closest to the Earth or furthest from the Earth. We have perigee and epigee. So an easy way to remember this is perihelion, when we were talking about planets, starts with the P. That's when we were closest. Aphelion was the furthest. The letters are the same. So apogee is when the moon is furthest from the Earth, and perigee is when the moon is closest. So maybe you can use kind of like the beginning letters of these words as kind of like a mental reminder if you remember what we talked about when we were doing sun nebula theory. So moon's orbit's elliptical. It rotates, as you can see, counterclockwise around the Earth. And as the moon revolves around the Earth, it rotates 1 time on its axis. But it's really slow. As it rotates on its axis and as the Earth kind of rotates on its own, it appears that the moon doesn't actually rotate, but in fact, it does rotate 1 time as it's going around Earth's orbit very, very slowly. So to us, it doesn't appear that it rotates. We always kind of see the same side of the moon. It's a very interesting phenomenon. So let's talk about lunar eclipses, how they work. So a lunar eclipse, what happens here is when the Earth is going to block part of the sun's light from striking the moon. And we have different types of lunar eclipses depending kind of the section of light that the moon is going to go through. Now you see over here on the right-hand side, there are these 2 words. We have umbra and we have numbra here, or penumbra, however you want to go ahead and pronounce that silent P. Umbra is the total shadow. So this is when we are totally blocking all of the light from the sun. And by we, I mean the Earth. The umbra, or the penumbra, however you want to try to remember it, is just a partial blocking of the sun's rays and light there. And depending where the moon kind of passes through in these shadows, you're either going to get a total eclipse in the umbra in the middle there, or if it passes just partially through this penumbra area here, that's where we're going to kind of a partial solar eclipse. So these very strange words are ones that you're going to want to be able to recognize to know, am I talking about a total solar eclipse or a partial solar eclipse here? This is another image to show the same thing where the umbra is. That is the total blockage of all of the sun's light by the Earth, or the penumbra right there, where it's just a partial shadow being casted by the Earth. There are 3 types of lunar eclipses that we'll deal with here. We have the penumbral eclipse, we have a total lunar eclipse, and a partial lunar eclipse. So the first one, penumbral, it occurs when the moon only passes through the Earth's penumbra right there. A total penumbral eclipse is when the moon is completely in the penumbra, but not in the umbra. This is a very rare type just because the area that is being taken up by the penumbra is very, very small. So in order to have the moon line up correctly on its slightly tilted orbit to pass through that partial shadow being casted by the Earth is very, very rare. We do not see that very often. And it kind of gives us this like yellow greenish glow look on the moon as it passes through kind of that partial shadow. It's losing some of that direct sunlight by the sun. So it's only reflecting back a partial amount there. So this is what a penumbral lunar eclipse looks like. That's the first time. Total lunar eclipse, this is a lot easier to recognize. It occurs when the moon travels completely into Earth's umbra. So the big main shadow casted by the Earth, it's when the moon passes into that. The totality of a total lunar eclipse generally lasts up to about 107 minutes. However, the time between the first contact with the shadow may last up to 6 hours and 14 minutes. So it's going to come into like that penumbra first, possibly, and then move into the umbra for that total lunar eclipse. So we can almost get like a series of eclipses going on here. So the total lunar eclipse generally only lasts a little less than 2 hours, and we get this kind of red, deep red blood moon thing going on here. Very cool colors associated with this. Partial lunar eclipse, it's only when part of the moon enters the umbra. It's not when it goes completely into the umbra or the penumbra. It's when it partially passes through the main shadow casted by the Earth. So a partial lunar eclipse is similar to a total, where we're dealing with the umbra, except this time, instead of having the whole moon go into the umbra, we're only really dealing with half of the moon going into the umbra there. Here's a little bit of additional information. That refraction of sunlight by the Earth's atmosphere into the shadow cone, it causes the moon to not completely disappear, and how we get the cool red color. So it's reflected sunlight by the atmosphere into the cone that allows that moon to kind of get that cool different colory hue. And then because of the moon's orbit around the Earth, it's slightly tilted at 5 degrees. Lunar eclipses do not occur at every full moon. So that's just because of that tilt is how we don't get total lunar eclipses every time we have a full moon. If we didn't have that tilt, very plausible, we would get these eclipses much more frequently. Every year, there's at least 2 different types of lunar eclipses going on. They may be viewed from anywhere on the night side of the Earth, which is a lot easier to do than our solar eclipses, and we'll get to that in a second. And here's a list of some relatively recent eclipses, especially with the one that happened very recently, May 16th, 2022. We had a total lunar eclipse here in Southeast Pennsylvania. It was a shame. It was cloudy that night. I went out to try to look. Couldn't really see it from my area here, but I did get information back that there were places in the United States that you were able to see the totality of the lunar eclipse. So very, very neat. Moving into solar, whereas in the lunar eclipse, the Earth passed between the sun and the moon. In this case, the moon is going to pass between the sun and the Earth, blocking it. So in this case, we have an umbra being created by the moon that is going to be cast on the Earth here. And on the picture, if you look real close, you can see that the total shadow is in a very, very small area. Whereas the partial solar eclipse, kind of that blue cone, that penumbra area in that blue cone is much, much wider. So in order to be able to be in the right location for a total solar eclipse, it's going to be a much more precise area than if you're looking for a partial. When does this generally occur? They generally occur during the new phase of the moon, which makes sense because, you know, we're not going to see the moon because the moon is going to be kind of between us and the sun in a new moon phase. None of the sun's light is reflecting off the moon back to Earth. So it's going to be a new moon phase when we're going to get solar eclipses. They're very rare, occurs somewhere on Earth approximately every 18 months. However, they recur at any given place once every 370 years. So if you have a total solar eclipse that passes over you, it's going to be about 370 years before it appears again in that same spot, which makes sense that there is a cycle because, you know, As the moon orbits the Earth, it orbits in the same pattern at the same angle, and the Earth rotates around or revolves around the sun at the same speed with the same kind of eccentricity and kind of orientation of its orbit. These only last for very few minutes because, you know, the moon's moving, the Earth is moving and rotating. So these generally never last more than maybe a little more than 7.5 minutes. A very, very short window of time for solar eclipses to occur. So 3 different types. We have total, annual, or annular, and partial eclipses. Again, total solar eclipse, very rare because the totality is only seen where that moon's umbra touches the Earth's surface, like I told you. It's when the sun is completely obscured by the moon. But the coolest thing about this is when we have total solar eclipses, and we mentioned this in the sun section, this is when you're going to be able to see the corona of the sun, the crown of the sun. Remember, corona is Latin for crown. So when we get a total solar eclipse like this is when we're going to be able to see that corona outline of the sun occurring. Very, very cool. For the annular eclipse, the sun and the moon are exactly in line, but the apparent size of the moon is smaller than that of the sun. This happens at apogee. So when the moon is the furthest point from the Earth, and we're getting a total solar eclipse, or we're getting a solar eclipse because of how, you know, far the moon is out, it's not close to us anymore. It's going to appear smaller, so it's not going to be able to completely block the sun's light from hitting us. Some of it will still come through, and this only happens at apogee when we have this annular eclipse. So maybe that's a good way of remembering. Apogee starts with A, annular starts with A. Again, letter association helps a lot. Partial eclipse, kind of like our partial lunar eclipse, when the sun and moon are not exactly in line, and the moon only partially obscures the sun. So when the moon passes partly in front of the sun, that's when we're going to get a partial solar eclipse. Why do the sizes of these two things appear to be the same? Well, it's all about distance and scale. Earth's distance from the sun is 400 times the moon's distance from Earth. And the sun's diameter is about 400 times the diameter of the moon. Because we have these very relatively equal ratios of distance and size, they appear relatively, you know, the same proportion in our sky. Yay, math. That's kind of a cool thing. And, you know, I honestly think that's a very rare situation for us here to have, you know, all of the different things to come in a line, to have these ratios very close to each other, to have these cool astronomical events occurring. When is the next solar eclipse visible from North America? Well, we had the one in 2017. Last year, there was an annular one. Very cool. Remember, that's when it's at apogee, when the moon is furthest away from us. And then in about 2 years in April 8th, 2024, we'll have a solar eclipse. So for those of you in my science class in April in 2024, if we're here during the week, guess what we're doing? We are going to play some solar eclipse, definitely on that day. These are some pictures of the eclipse that Miss Gallagher took during the 2017 solar eclipse. Very cool. Again, remember, it's not too safe to look directly at the sun, especially during an eclipse. So that's why you always kind of want to use some sort of technology to help out with it. So that's the end of our discussion on eclipses, solar eclipse, lunar eclipses. And the next video will be our last main video, I should say, for the astronomy section, where we talk about how the moon affects tides. So if you like this video, thank you. I appreciate you. If you have any questions, please go ahead, ask. If not, have a good rest of your day, and we'll see you next time. Goodbye.